Okay, so whatever we have seen yesterday in last lecture, so anybody is having any problem? We have seen in last lecture the channel of capacity, the capacity formula we have seen. That is Nyquist Shannon capacity formula. Some examples we have seen. Also, we have seen transmission impairments. What is mean by the transmission impairments that we have seen? Anybody is having any problem? What is transmission impairment? Can anybody tell? What is transmission impairments? Can anybody tell? Yes. What is transmission impairments? In last lecture we have seen this. Hmm? Transmission impairments means what? What are the types of the transmission impairments? Yes. What are the types of the transmission impairments? Noise, delay, distortion that we have seen. Huh? So what is transmission impairments? Everyone. Sanika Thakre, Sankit, Sheetal. Hmm. Vaishnavi, Omraj. Tell me what is transmission impairments? We have seen in last lecture. Yeah, this we have seen. Whether my screen is visible?
Yes, ma'am.
Screen is visible. So what is transmission impairments? Huh? So
Attenuation,
imperfection. Huh. Attenuation, delay, distortion, and
Noise.
noise. These are the
noise,
three transmission. Yeah, transmission impairments. So what is transmission impairments is whenever a signal travels through a medium, right? So due to some external effects or internal causes, there are some signals are getting changed. Means whatever signal is sent by the sender, that is not matching exactly with the receiver, and that we call it as a transmission impairment. सिग्नल जो सेंड झालेला आहे त्याच्यामध्ये काहीतरी चेंज होतो आणि तो सिग्नल ऍज इट इज रिसिव्हरला रिसीव्ह होत नाही. That is nothing but an impairments. Okay, so there are three types: attenuation, distortion, noise that we have seen. Attenuation means what? Loss of energy. If the signal travels through a medium and distance is getting increased, then by the as the distance is increasing, the energy or the signal is getting lost. That is nothing but the attenuation. And to reduce the effect of the attenuation, we are using the amplifiers, which is working as a boost for the your signal amplifiers. How these are used, what is the purpose, everything we have seen. Then how, what is the formula for measuring the attenuation is this. Okay, is equals to 10 log to the base 10 P2 by P1. P2 is output and P1 is input signal. Then next we have seen some of the examples for this. Then distortion. Distortion means what? Signal changes its form or shape. You can see here. This is the original signal, but it is changing like this. Means the shape of the signal is getting changed, and that is the reason that receiver is not getting exact signal. That is nothing but the distortion. And third one is the noise. Noise means what? Unwanted signals are added in original signal. That is nothing but the noise. ओरिजिनल सिग्नल मध्ये एक्सटर्नल एक्स्ट्रा सिग्नल ऍड होतो which is unwanted, and due to this the shape of the signal is getting changed. It is not continuous. User will not get any pattern through this signal. So this is nothing but the noise. So there are some types of the noise that we have already seen. Then we have seen capacity of the channel, means how much data can be transmitted through the transmission medium, that we have seen. What is the capacity of that medium, that we have seen. Okay, so two formulas we have seen. First one is the Nyquist capacity formula, and second one is the Shannon capacity formula. So Nyquist capacity formula is given as C is equals to 2b log to the base 2 raised to n. N means level of signal. What is that? That we have seen. C is the capacity. B is the bandwidth. Right? So that already we have seen. Then we have seen some of the examples. Then Shannon capacity formula. So Nyquist capacity formula is designed for noiseless channel. Assumed that it is assumed that there is no noise present in particular channel, but for the Shannon capacity formula, it is assumed that the capacity is calculated for the channel where noise is present. Okay, so the formula is C is equals to B log to the base to 1 plus SNR. SNR stands for signal to noise ratio, and B is bandwidth. So using this formula, we can calculate the capacity of a channel. So this part we have seen in last lecture. Okay. So next, in for today, we are going to see a very much important point for or the point which in or definitely one or two points are there regarding this point. So it is very easy. Just we need to pay attention how the particular signals are traveling through the medium. So just pay attention. The point is data encoding and decoding. Okay, so data encoding and decoding. So what is this? Encoding is the process of converting the data or given sequence of the characters, symbols, alphabet, etc. into a specified format for the secure transmission of a data. Okay, encoding is the process of converting the data or given sequence of characters, symbol, alphabets, etc. Meaning is what? Whatever message or whatever data sender wants to say, that data is being converted into a specified format, and the purpose of this conversion is secure transmission. That is nothing but the data encoding. Okay, so data encoding means what? Converting a data or the characters or symbol or alphabets, whatever information or whatever message user want to share, that message is being converted into a specified format for secure transmission. That is nothing but the data encoding. So data encoding is happening at the sender side, राईट. सो सेंडर जो मेसेज सेंड करणार आहे त्याला कन्वर्ट केलं जाईल ट्रान्समिशनसाठी. सो एन्कोडिंग इज happening at the sender side, and whenever receiver receives that message, the decoding of that message is done. So decoding is reverse process of encoding, which is to extract the information from the converted format. So decoding means what? Whatever data is original data is converted or encoded, that should be in a original format. That is nothing but the decoding. So decoding will happen at the receiver side. In short, encoding and decoding is nothing but encryption and decryption of a message. इन्क्रिप्शन मीन्स ओरिजिनल मेसेज ॲज इट इज ठेवला जाणार नाही. त्याच्यामध्ये तो कन्व्हर्ट केला जाईल इन एनी फॉर्मॅट. कशासाठी? तर ट्रान्समिशन सिक्युअर व्हावं यासाठी. आणि डिक्रिप्शन और डिकोडिंग म्हणजे काय? रिसिव्हर साईडला जेव्हा तुमचा मेसेज जाईल त्यावेळेस encrypted message will not get understood by the receiver. So to get understood the original message, that message is decrypted or decoded and original message will be received by the receiver. ठीक है. So data encoding and decoding. Yes. Anybody is having any problem? My screen is visible, no?
Yes, ma'am.
Sorry. Okay. So next, there are some whatever we are going to see, that is nothing but that is related with the data encoding part. Okay, so there are some types of the encoding such as polar encoding, then digital to digital encoding or digital data to digital signal encoding, likewise. So we'll see one by one. First one, polar encoding. Polar, it is also called as a unipolar. Okay, so polar encoding or unipolar is same. Unipolar signaling is also called as an on-off king or simply OOK. So meaning is what? Whenever a data is there or signal is there, it is represented in 1 and 0 format, right? So according to the data, the signal is getting generated, and for every 0 and every 1, there must be some specified format that how this 0 and 1 should be represented. So in case of the polar encoding, the presence of the pulse represents a 1 and absence of a pulse represents a 0. Means what? Presence means this signal or the particular format is getting generated. So it is represented as 1 and absence of a pulse represents 0. Means this one, absence. You can see here. Whenever 0 is there, uh, signal is getting absent. So whether this data is being converted into signal or signal is getting converted into the data, so it will depend upon the question. So जसा question असेल तसा, maybe they will give you signal and you have to retrieve the data, or the data can be given and from that you have to generate the signal. How that data should be represented, that depend upon the question. आता इथं काय सांगितलंय चेक करा. पोलार एन्कोडिंग मध्ये काय असतं तर 0 आणि 1 दोघांचा एक स्पेसिफाईड फॉर्मॅट किंवा स्पेसिफिक हे पॅटर्न डिसाइड केलेलं असेल आणि त्याच पॅटर्न मध्ये तो डेटा फ्लो होईल. तो जर 0 असेल म्हणजे काय असणार आहे तर सिग्नल अबसेंट असेल. सो धिस वन. आणि 1 म्हणजे काय तर सिग्नल प्रेझेंट आहे. 1. So you can see here 0 absent, 1 signal is present, again 0 absent, again 1 present, again 0 absent, then present, again 1 is there, again it is present. So this diagram is called as a signal diagram or timing diagram, we can say. So the data is given, we can draw the signal, or if signal is given, we can retrieve the data. Okay, so that is nothing but the polar encoding. Then next type, digital to digital encoding. It is nothing but the representation of digital data by using digital signal. Representation of digital data. Digital data means what? 1-0 format. And this data is encoded and it is represented using digital signal. That is nothing but the digital to digital encoding. Now, you can see here 1010, the data is given in digital format. Some techniques are used. What are these techniques? Next slide, I'll explain. And this data is represented in this format. So you can see here. 1 is there means signal is on, then 0 is there means signal is off, again 1 signal is on. You can see here on off is there, 1 is there, then 0, again 1 off, 1 off. Likewise your signal will get generated. It is not fixed at all that this signal will vary same for every technique over here. इथं जे एन्कोडिंग साठी टेक्निक्स वापरलेल्या आहेत त्या प्रत्येकासाठी 1 म्हणजे प्रेझेन्स ऑफ सिग्नल आणि 0 म्हणजे अब्सेन्स ऑफ सिग्नल असेलच असं नाही. इट विल व्हॅरी अकॉर्डिंग टू द टेक्निक्स. इथं कोणती टेक्निक आपण यूज करतोय त्याच्यानुसार हे तुमचं 1 आणि 0चं मिनिंग चेंज होत नाही. Okay, so that is nothing but the digital to digital encoding. We are having the digital data, and that data we are encoding to represent it, and for that encoding we are using some techniques over here. That is nothing but digital to digital encoding. So let's see which are the types of this encoding. So these are some of the techniques, encoding techniques which are used. According to this diagram, we are using these techniques over here. Okay, means we are having this data, we are applying this technique, and we are going to represent the data or the signal. Let's see some of the techniques. For polar representation, these are the two techniques, NRZL, NRZI, and for bipolar encoding, Manchester and differential Manchester. These are some of the techniques. Again, there are sub techniques that we are also going to see. What is this NRZ Manchester? I'll explain you deeply, don't worry. So up to this, am I clear? Hmm? What is the purpose of this encoding, data encoding and decoding? जो डेटा आपण सेंड करणार आहे त्या डेटाला सिक्युअर करायसाठी तो डेटा कन्वर्ट केला जातो आणि ह्या प्रोसेसला काय म्हणायचं तर एन्कोडिंग म्हणायचं. मग एन्कोडिंग कोण करतो तर सेंडर करे किंवा सेंडर साईडला होईल. आणि डिकोडिंग म्हणजे काय, ज्यावेळेस डेटा रिसिव्हरकडे रिसिव्ह होणार आहे त्यावेळेस तो डेटा जो एन्क्रिप्टेड असेल किंवा एन्कोडेड असेल रिसिव्हरला अंडरस्टूड होणार नाही. त्यामुळे तो ओरिजिनल फॉर्मॅटमध्ये आणण्यासाठी त्याला डिक्रिप्ट करावं लागेल किंवा डिकोड करावं लागेल. दॅट इज नथिंग बट द डिक्रिप्शन ऑर द डिकोडिंग अँड विच इज हॅपन ॲट द रिसिव्हर साइड. Okay, then next, these are some types. We'll see one by one. So first type for this is NRZ. NRZ. So it stands for non-return to zero. It stands for non-return to zero. So you can see this diagram, this one. So in all the examples henceforth, जे काही आपण examples बघणार आहे किंवा जे काही formats बघणार आहेत, for that this will be your zeroth line. This side will be positive and this side will be negative. Okay, so this is 0, then this will be the positive side, and below that this will be the negative side. Now let's see what is NRZ. Non-return to 0 means whenever signal travels at that time, it will not return or it will not stop to the 0th line. That is nothing but the NRZ. It uses two different voltage levels to represent binary values. So as I told you, two different levels means one is positive and one is negative. I'll show you. See here. So here it will be a positive side and here it will be a negative. Okay, and this will be a zeroth line. So in case of the NRZ, if the signal is started or ज्यावेळी signal चालू होणार, at that time it will not stop at this zeroth line. Either it will be at positive side or negative side. So that is nothing but the NRZ. Okay. So generally positive voltage represents 1 and negative value represents 0 in case of the NRZ. So it means that 1 represents high to low signal and 0 represents low to high signal, right? So let's see one example we will see, from that you will get understood what is NRZ. There are two types of this NRZ. First one is the NRZ-L, that is nothing but the L stands for, this L stands for level, means never return to the zeroth level. The meaning is that. Okay, S stands for level, and I is nothing but the invert, that I will tell you in next slides. So, as I told you, what is given here? 1 represents high to low and 0 represents low to high. Okay, now we are having this digital data 0101 in this format. From this, we have to generate the signals. Means if this is the data and the type or the technique is NRZL, then how my signal will look like, that I have to represent. So I'll write here 0 means what? It is low to high. In short, I'll write, and 1 means what? It is high to low. Okay, let's draw the signal. Now, first is what? 0. In case of the NRZ, you can start with either negative side or positive side, anything. Okay, so accordingly, your signal should travel. You can start from this side or this side, anything. So let's start from the negative first. Okay, so it is 0, because in case generally general representation is what? 0 represents the negative. Okay, so we are having first bit as a 0. So I'll start from negative side over here. So 0 is what? 0 is what? Low to high. Let's see how the signal is travel. So low to high, like this. थोडस लक्षात घ्या. थोडस लाईन्स इकडे इकडे होतील, बट यू हॅव टू ड्रॉ द लाईन एक्झॅक्टली सेम. हे सगळे जे आहेत 0101, याला काय म्हणायचं, तर टायमिंग स्लॉट्स म्हणायचे. विदिन दिस टाइम 0 will travel, within this time 1 will travel, within this time 0 will travel. Now next bit is what? 1. So 1 represents high to low. So see here, high to low, it will go over here. Again 0 is there, again 0 will represent low to high. Again 1 is there, so again high to low. Again 0 is there, so low to high. Again 1 is there, so now 1, again 1 is there. See here, so what will happen? It will go this, and again 1 is there, so it will get continued, and then it will go back, or it will be the low. Again 0 is there, so again low to high. Again 0 is there, it will get continued. Again 1, again it will go up and high to low. So this will be my signal representation for this data in case of the NRZL. Am I clear? Am I clear?
Yes, ma'am.
Yes,
Okay.
ma'am.
सगळ्यांना समजलंय. टेक नोटबुक, पेन सगळं घेऊन बसायचं. नेक्स्ट एक्झाम्पल्स तुम्हाला सॉल्व्ह करायचे आहेत. हे सगळ्यांनी ड्रॉ करून घ्यायचं. ठीक आहे, ड्रॉ करा, अदरवाइज जस्ट लिहून घ्या. व्हॉट द 0 रिप्रेझेंट, व्हॉट द 1 रिप्रेझेंट, what is positive and negative side. Okay, I'll wait for 2 minutes only. Within that, just draw this diagram and arrange all the things fast. Over.
Yes, ma'am.
Okay. Others. झालेलं आहे. Can
Yes,
we
ma'am.
go? Okay, can we go for the next slot or next example? Same example is there NRZL. I'll explain over here. By the time those who have understood, they can draw by their own. Those who have not understood, please see once again. So here, those who understood, start your example solving so that you will check whether you are correct or not. So as usual, it is 0, then this one is positive, this one is negative. 0 represents low to high, 0 will be low to high, and 1 will be high to low, high to low. Okay, so let's start. So as usual, always starts from a negative side or positive side. It is depend totally upon you. But again, first bit is 0, so generally start from negative side. So 0 is what? Low to high. Low to high means what? Negative to positive. And high to low means what? Positive to negative. Okay. Then 1 is there, so high to low. Again 0 is there, so this one same. Again 0 is there, so continue the signal. Again 1 is there, so high to low. See here, high to low means in between I can't leave the signal. इथं हाय टू लो आहे म्हणून मी हा असा सिग्नल काढू शकत नाही. कारण का? तर इन बिटवीन हा सिग्नल काय होईल? ब्रेक होईल. सो टू रिप्रेझेंट वन ॲज अ हाय टू लो, आय हॅव टू कंटिन्यू दिस सिग्नल to the level of positive. Okay, then high to low. Again 1 is there, continue the signal. 1 is there, so continue. 0 again go back and represent as a low to high, and again 1 is there, so high to low. Clear? So 0 1, again 0 0, then triple 1, then 0 and 1. Those who are drawn, check it whether it is correct, whatever you have drawn. Is it correct?
Yes, ma'am.
हाँ मैम.
Yes, ma'am.
Okay, so understood. Hmm?
Yes, ma'am.
So yeah, it is easy. Just you have to remember what is 0 and what is 1. Again the third example. Now everyone has to solve it. See, I'm not able to see what you are doing, but it is an humble request that everyone should do by their own. Hmm? So just draw the signals for this one. Okay, so here is 0, this will be positive, this will be negative. 1 is there, so we can start the signal from positive side. So 1 is representing high to low, so high. to low. The 0 represents low to high. So again, this will be like this. Again, 1 is high to low. Then 0 is low to high, continue. Then again go up for 1, again 1, again come back, again 0. So this will be the representation of this data. Is it okay?
Yes, ma'am.
Yes, ma'am.
आलंय सगळ्यांचं?
हो.
Okay.
Yes, miss.
Okay. So
Yes, ma'am.
okay, question
No, ma'am.
मे बी डेटा दिलेला असेल दिस वन आणि तुम्हाला सिग्नल ड्रॉ करायला सांगितलं असेल और सिग्नल दिलेला असेल आणि ह्या सिग्नल पासून डेटा काय होईल किंवा काय येईल हे विचारलं असेल डिपेंड्स ठीक आहे अगेन लास्ट एक्झाम्पल सॉलिड 0 then positive then negative 0 represents or it starts from negative again there then go up for 1 then this one again 0 is there go up for 1 continue again 0 again go up then 1 1 1 go back 0 0 and go up for 1. So this is NRZL. Okay, NRZ. So you can see in any of the example we have not stop our signal represent for this zeroth line. Put a stop केलंय का? No. This is your 0. So this is NRZ non return to 0. Never return to 0. ह्या पॉइंटला थांबायचं नाही. Either positive or negative. So this is nothing but the NRZL. Everyone clear? Can we
Yes,
go
ma'am.
forward?
Huh, ma'am.
Yes.
Yes, ma'am.
Okay, okay. So let's go to next point. So next type of the encoding is NRZI. Okay. So non-return to zero invert. It stands for non-return to zero invert. So what is the meaning of this is what if one occurs at incoming signal, then there occurs a transition at the beginning of a bit interval. If one occurs at the beginning, if one occurs at incoming signal, then there occurs a transition at the beginning of the bit interval. And for a 0 at the incoming signal, there is no transition at the beginning of a bit interval. And 1 and 0 starts from a negative. Okay. So it is same as the NRZL. फक्त आपण NRZL मध्ये 0 म्हणजे काय म्हणत होतो की लो टू हाय आणि 1 म्हणजे काय म्हणत होतो हाय टू लो. Instead of that, what we have to say here is 1 means presence of a signal and 0 means absence of a signal. That is only difference is there. Let's see. Again 0, then positive and negative. What is told is that 1 or 0 always starts from a negative side. 1 also or 0. याच्यामध्ये काय होतं इकडं फॉर एक्झाम्पल दिस वन वी हॅव स्टार्टेड फ्रॉम पॉझिटिव्ह बिकॉज 1 is present and if 0 is present we are starting from the negative, but in case of the NRZI either 1 or 0. For both, we have to start from a negative side only. Okay, so let's see. So first bit is 0, so we have to start from a this one negative side. Now next 1 is there, means there is a presence of a signal, so again go up, then 1. Okay, then again 0. Now for this 0, the meaning is what? Absence of a signal, means we have to continue like this. Again 1 means presence of a signal, so like this. Again absence of a signal, 0, so continue. 1 inverted. Okay, 1. Now invert's meaning काय check करा. How I am writing or how I am drawing. Now in earlier case, in case of the NRZL, if this one is present and this one is present, we are continuing the signal because it was representing as a high to low. But in case of the NRZ I stands for an invert. It means that whatever signal level is there, do exactly reverse of it. Now I have to draw the signal like this. Okay, again 0 is there. So there should not be the signal, absence of a signal. Again 0, continue. 1, again go up and represent. Am I clear? So NRZI means what? Invert. It always starts from a negative side. Either first bit is 0 or 1, whatever. So I have started signal from negative, is the 0 means absence of a signal. So this one. Again 1 is there. So invert for 1, there is a presence of a signal plus inverting. Invert means what? जर मी निगेटिव्हच्या साईडला असेल तर मला पॉझिटिव्ह साईडला जायचंय आणि पॉझिटिव्हला असेल तर निगेटिव्ह साईडला जायचं. दॅट इज नथिंग बट द इन्वर्ट. नाव आय एम हिअर, सो आय हॅव इन्वर्टेड द सिग्नल ॲज अ positive side. Again 0, no signal means continue as a absence of a signal. Then again 1, as it is positive side, again come back to the negative side. Then 0, absence of a signal. 1, again opposite side. Again 1, opposite side. 0, absence of signal. Again absence of signal. 1, again opposite side. That is nothing but the NRZ clear? Okay, one more example I'll show you. Okay, so 0011 is the example. Okay, this starts from here is the 0, this one is positive and this one is negative. I'll draw one more line over here. Now see, first is what? 0, but we have to always start with the 0 only, and there is, whenever 0 is there, absence of a signal means absence. Again absent. Next bit is what? 1. So it should be invert and presence of a signal. So go up for 1 and present of a signal. Again 1, again come back and present of a signal. Again 0, continue. 1, again go up and this one. Again back, sorry, it is not, it is wrong. This and continue. It is wrong. This one. Again 1, again go back and presence of the signal. Again 1, again go back, present of a signal. Again 1, go back, present of a signal. Then 0, continue. Again go back and presence of a signal. Clear? समजलं? NRZI? Yes or no?
Yes, ma'am.
सगळ्यांना
Yes, ma'am.
सगळ्यांना समजलंय
Yes, ma'am.
एनर्जी. ओके, एनर्जी आहे. सो रिमेंबर what the 0 represent, it is an absence. Absence म्हणजे कंटिन्यू, फक्त तिथं पॉझिटिव्ह किंवा निगेटिव्ह साईडला सिग्नल न्यायचा नाही. आणि 1 म्हणजे काय? जर मी पॉझिटिव्हला असेल तर माझं सिग्नल रिव्हर्ट होऊन कुठे येईल? निगेटिव्ह साईडला. आणि जर मी निगेटिव्हला असेल तर इन्व्हर्ट होऊन तो पॉझिटिव्ह साईडला येईल. दॅट इज नथिंग बट द वन or NRZ R. Clear? Now solve this example. Next example. Solve it. Okay, so let's see this example. Here it is 0, then this positive. You can draw by your own and again check it. Okay, so let's start from a 0. So here, then 1, go up and draw. Again 0, continue, continue. Again 1, come back to the positive side. Again 1, invert it. Again 0, 0, 0. Again 1, so invert it. So this will be the signal representation. Are they correct?
Yes, ma'am.
Yes, ma'am.
Nobody is having any problem. कोणाचं आलं नसेल तर प्लीज आस्क, आत्ताच विचारा, आत्ताच वेळ आहे.
Ma'am, repeat once again.
NRZ I रिपीट करायचं आहे ना?
हाँ मैम.
Yes, ma'am.
ओके, हे नवीन एक्झाम्पल आहे. लिसन. ओके, दिस इज अवर झिरोथ लाईन, दिस इज अवर पॉझिटिव्ह, इट इज अवर निगेटिव्ह. ठीक आहे. सो इन केस ऑफ द NRZ झिरो मीन्स व्हॉट? देअर शुड नॉट बी नो ट्रान्झिशन, म्हणजे तिथे तुमचं सिग्नलच दिसणार नाही. ठीक आहे. 0 मीन्स नो ट्रान्झिशन. अँड 1 म्हणजे काय असतं तर प्रेझेन्स ऑफ अ सिग्नल, म्हणजे तुमचं सिग्नल प्रेझेंट आहे पण तो काय करणार आहे, तुम्हाला इन्व्हर्ट करेल. इन्व्हर्ट करेल. नाव इन्व्हर्ट मीन्स व्हॉट? सपोज जर मी पॉझिटिव्ह साईडला असेल तर मला निगेटिव्ह साईडला सिग्नल आणायचं आहे, आणि जर मी निगेटिव्ह साईडला असेल तर मी कुठे येणार? पॉझिटिव्ह साईडला येणार. दॅट इज नथिंग बट द इन्व्हर्जन. लेट्स सी. अँड फॉर 1 आणि 0, आता हा फर्स्ट बीट कोणता आहे? माझं 1 आहे. 1 च्या ऐवजी जर माझं 0 असता, in both the cases my signal should always start from a negative side only. That are the rules for this representation. Now let's see. First is what? 1. So as the rule is what? We have to always start from a negative side. So for this one, again, what is the next bit? It is 0. 0 means what? There should not be any transition. This what? I have to continue like this. There should not be any transition. म्हणजे काय? झिरोतला मला काय करायचंच नाही. करायचं नाही म्हणजे काय? तर तो सिग्नल जो माझा प्रिव्हियस आहे तो ऍज इट इज फ्लो होईल. Okay, that is the meaning. Again is what? 1. 1 means what? Presence of a signal but invert. Invert means what? Now where my signal is at negative side, so I have to go to the positive side and then my signal will be available. Again 0 means I should not do anything, so continue as it is. Again 0, again I have to continue as it is. Again 0, I have to continue as it is. Now again 1. Now my signal is at positive side, so I have to invert this signal to the negative side and I have to represent it as a positive or as a 1. Again 1 is there, so now I'm at a negative side. Again go up to the positive side and represent the signal. Now 0, there should not, I mean I should not do anything, so continue the signal. Simple. आता सपोज माझं परत इथं 0 असेल. Okay, so 0 ला काय आहे? Again it will get continued. Suppose now here it is 1. 1 आहे means what? पुन्हा माझं सिग्नल इन्व्हर्ट होईल like this. सो जसा डेटा आहे तसा माझा सिग्नल व्हॅरी होत जाईल. क्लिअर? समजले?
Yes, ma'am.
दोज
Yes, ma'am.
सगळ्यांना समजलं? So remember, हे सगळे एक्झाम्पल्स मी शेअर करेन आज. You just draw and check it whether your signals are represented correctly or not. So these are the two types of the NRZ, non-return to zero. Again, non-return means never stop your signal to this zero line. या लाईनला स्टॉप करायचा नाही तुमचा सिग्नल. So either positive side or negative side. That is the NRZ. ठीक है. Then next type is bipolar AMI. Okay, bipolar AMI. It stands for alternate mark inversion. AMI stands for alternate mark inversion. Now, what the zero represents over here? Zero means no line signal, and one means positive or negative pulse alternatively in polarity. One means positive or negative pulse alternatively in polarity. Now let's see how this signal is drawn. Okay. So here it's zero, this one is positive, this one is negative. Now what is said over here? Zero means no signal line, and one means positive or negative pulse alternatively in polarity. Now here it is the second type, that is bipolar. In case of the NRZ, we are distributing or we are drawing the signal at the positive or negative, and we are not starting or ending our signal at zeroth line. But in the case of the bipolar, we have to start our signal from zeroth line, or we have to end our signal at the zeroth line, because it is totally different from the NRZ. Now, let's see what is or how the signal can be drawn. So zero is no inversion or no signal is there, and one means either positive or negative. So that is the meaning. Let's see. So zero means no inversion, and we have to take the help of the zero line. So this will be my signal for zero. Now, what is the representation of one is positive or negative pulse alternatively. Means what? If this one is representing the positive signal, the next one should represent the negative signal alternatively, right? So let's see. Suppose this one is representing positive line. Okay, then again zero is there, so my signal will be this one. Now one is there, so this one is at the positive side, this one is at the positive side, so this should be at the negative side, like this. It is returning to zero, remember. Okay, again zero is there, so 0. Okay, then 1. Now it is at the negative side, so next one should be at the positive side. Okay, again 1 is there, so again go to the negative side. Again 0, this one. Again 0, this one. Now it is at the negative side, so draw it. The next one should be at the positive side. Simple. Understood? Hmm?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay,
Yes,
zero means we have used the zeroth line. In case of the NRZ, we are drawing the signal either at this positive side or negative side. It is not returning to the zeroth level. But in case of the bipolar AMI, we are using this line. So zero means no signal, means this line we have to consider as a no signal. Then one should be positive and negative alternatively. If first one is at the positive side, then second should be at the negative side. You can draw it any way. ठीक आहे. So this will be like this also. इकडे पण तुम्ही काढू शकता first one. anything. It totally depends upon you how to write. कुठलंही काढू शकता, either this or this. फक्त depending upon the first one, the next should be drawn at its exactly opposite side. That is nothing but the bipolar AMI. Okay, let's see one more example. If you have understood, solve it by your own, and those who have not understood, again let's see the example. So positive, negative, 0 means no signal, and 1 means either positive or negative. Let's see. 0 is absence of a signal. 1, now I'll take it at negative side. This one again, 0 is there, 0 continue, again 1 is there, now it should be at the positive side, again it should be at the negative side, again 0, sorry, again 0 is continued, and again go to the positive side. Ale?
Yes, ma'am.
Ma'am,
Yes,
ma'am, which one we should have to take first, positive or negative?
this one first bit.
नाही मॅम, जेव्हा वन येतं ना, मग
it
आता हे
it
पहिलं
would,
वन आहे ना, ते
ha,
निगेटिव्हला घ्यायचं का वरती पॉझिटिव्हला घ्यायचं?
it depends upon you. You can take either negative or positive. That's why
ओके.
in first example I have taken it at the positive side, and in the second example I have taken it at the negative side. It depends totally upon you. तुम्ही कोणतेही घेऊ शकता, either positive or negative.
ओके
Clear?
मॅम, ओके.
फक्त
येस.
जे फर्स्ट घ्याल त्याच्यानंतरचा जो वन असेल तो रिव्हर्ट घ्यायचा, म्हणजे रिव्हर्स घ्यायचा त्याच्या विरुद्ध.
हा मॅम.
ठीक आहे. Then next one. Solve this example. Same example. Done?
Yes, ma'am.
Okay. I have, now please show the question. Okay. Yeah, this one. This is the question. So I'll draw this one, positive, negative. So as it is 1, so let's start from positive side. This one, 0, then 1, so it should be at this side, again 0, and 0, 0, negative means positive, again this one, and this one. Check it, those who have solved, whether it is correct or not. Any doubt?
No, ma'am.
No, everyone has got the answer ना. प्रत्येक जण
Yes.
करताय ना सॉल्व, प्लीज सॉल्व. आता समजेल पुन्हा हा सिग्नल कसा आला, काय आला, नंतर जर स्टडी करू म्हटला काहीही येणार नाही. रिमेंबर, काहीही आठवत नाही. आणि बुक जर वाचायला गेलात किंवा माझ्या दिलेल्या जरी नोट्स तुम्ही वाचायला गेलात, स्टील you will not understood anything. जोपर्यंत आता वेळ आहे तोपर्यंत हे एक्झाम्पल सॉल्व्ह करून घ्या प्लीज. नंतर बुक मध्ये काय दिलेलं असणार आहे, हा वन इज दिस दिस दिस, बट वाय दिस, इट शुड गेट क्लिअर हिअर ओनली. Okay, then again solve this example. I'm taking 4 examples of every type so that you will understood it properly. Okay, so I'll draw, you can also draw with me. So 0 is there, so 0 0, then 1, so this one positive side, again negative, then 0, then positive, again 0, then negative, positive, again negative, and 0. Check it. Have you got the same signal?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Oh, good
Yes,
one,
ma'am.
good. So everyone has got it. Good. Okay. The next type is pseudo ternary encoding. Pseudo ternary encoding. So it is exactly reverse to the bipolar AMI. It is exactly reverse to the bipolar AMI. It is nothing but 1 is the absence of line and 0 is positive or negative alternatively. So whatever we have done here for 0, that we have to do for 1, and whatever we have done for 1, that we have to do for 0. Okay. So 1 म्हणजे काय असणार आहे, absence of a line, and 0 is positive negative. So try it. तर तुम्ही ट्राय करा काय कसा येईल ह्याचा सिग्नल. चेक इट. Okay, let's see. Check it whether your signal is correct or not. Positive, positive with a negative. Again, 0 means positive or negative. So let's start from positive. Then 1, absence, 0, negative, 1 is absence, 0, positive, 1 is absence, 1 is absence, again 0, negative, then positive, and 1. Check it. Is it correct?
Yes, ma'am.
Yes, ma'am.
Okay. Everyone, others. I'm getting answer from same people every time. I can
हाँ, ma'am.
understand.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. समझ रहे ना? Okay. Yeah. Solve the next examples. Solve it.
Okay,
So
ma'am.
I also draw. झालं?
Yes.
Yes.
Negative. Then, okay, I'll also draw so that everyone can check it. Then negative, then absence, absence, then again positive, then negative, again positive. आणि ठीक आहे, am I clear? आहे बरोबर हा सिग्नल? Okay, next example. Sorry. Solve the example. One, this one, negative. Check it. Is it correct?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Last example. Yeah, last example answer sheet. See this. Got the same signal?
Yes, ma'am.
Yes, ma'am.
Okay. Anybody is having any problem in these two types?
No, ma'am.
No,
Hmm?
ma'am.
No. Everyone has understood. Hmm?
Yes.
Remember difference. डिफरन्स लक्षात ठेवा हा. एनआरझेड एल ला आपण काय करत होतो किंवा एनआरझेडच्या दोन्ही टाईपला झिरो लाईन कन्सिडर करत नव्हतो आयदर पॉझिटिव्ह आणि निगेटिव्ह आणि त्याच्या पुढचे जे सगळे टाईप आहेत एनआरझेड सोडून तर प्रत्येक टाईपला काय करायचं आयदर पॉझिटिव्ह निगेटिव्ह कन्सिडरिंग झिरो झिरोची लाईन आपल्याला कन्सिडर करायची आहे. बायपोलर एएमआय मध्ये एएमआय त्यामध्ये काय होतो वन रिप्रेझेंट्स इज positive or negative and zero represents absence and in case of the pseudo ternary exactly reverse of AMI. Zero represents positive or negative alternatively and one represents absence of an. ठीक है. So next encoding techniques. It is also called as the biphase encoding technique. Biphase encoding technique. The reason is that in case of the biphase encoding techniques, it always or every signal is represented at the middle of this line only. Okay. So what is the meaning of this is what? Suppose this is my 0, sorry 1 and this is my 0. So it should it is represented means in earlier examples याच्या आधीचे जे होते ते आपण कसे रिप्रेझेंट करत होतो फुल ही लाईन घेत होतो for 1 or 0 whatever it is. Okay, but now in case of the biface this signal should represent like this, means at the middle of this line it should end over here. ह्या 1 च्या middle ला start होईल तो आणि 0 च्या middle ला end होईल. Similarly suppose 0 represent करायचं असेल मला तर तो असा होईल. ठीक आहे. नेक्स्ट सपोज 1 असेल तर तो असा होईल. That's why it is called as the biface encoding. Okay. So what is this biface encoding? Let's see. The signal level is checked twice for every bit time. Signal level is checked twice for every bit time, both initially and in the middle. So as I told you, signal level तुमचा initial ला पण असणार आहे आणि middle ला पण असणार आहे. So that is nothing but the biface. Hence, the clock rate is double the data transfer rate, and thus modulation rate is also doubled. Okay, the clock is taken from the signal itself. The bandwidth required for this encoding is greater because it travels from the middle. So middle ला travel होते म्हणजे काय की तो signal start obviously it should start from the start of the your uh, timing line. Okay, and then it should get travel. So that's why the bandwidth required for this is higher. There are two types of this biphase encoding. First one is the biphase Manchester and second one is the differential Manchester. Biphase Manchester is also called as only Manchester. Biphase ला दुसरं नाव आहे only Manchester and differential Manchester is also called as a differential Manchester is also called as a D Manchester. Okay, D Manchester. The name biphase or Manchester and differential Manchester means D Manchester. These are the two types. Let's see what is this the Manchester and differential Manchester. So Manchester or biphase Manchester, in this type of encoding the transition is done at the middle of the bit interval. So as I told you, transition it will be at this middle of the interval for both the types. Okay, the transition for the resultant pulse is low to high in the middle of the interval for input bit 1. If it is 1, what it will represent? From low to high. Low 1 will represent low to high, and while the transition is from high to low for the bit 0. So 0 ला काय असणार आहे? High to low. So that will be the consideration for 1 and 0, and it should always start or the signal will be from middle of the line only. So let's see example from this you will get understood. So Manchester encoding. So I'll write over here first. So 1 will be low to high. Every time you just remember these techniques. Okay, what should be the 1, what should be 0 for every encoding type. आणि ज्यावेळेस तुम्हाला एक्झाम्पल दिलेलं असेल फर्स्ट राईट दिस राईट लाईक दॅट लाईक दिस so that while drawing you will also get understood what should be the 1 and what should be the 0. Okay, so 0 should be the high to low, and as it is Manchester it should be at the middle of the bit interval. So let's see how it is represented. So as it is NRZ not an NRZ, so always it should end or we have to consider this zeroth line also. Okay, so let's see or let's draw this signal. So 1 represents low to high. So low to high means like this or sorry like this low to high, and high to low means what? This one like this. The signal is generally represented. So 1 I'll start see carefully because it is quite difficult. So 1 is what? Low to high, like this. Where it is started, this one came to the middle of the interval, and then it changed its position. In all earlier example, how we are writing, how we are representing, for example, this one and this, but now we have to write it, or we have to draw at the middle. That's why this, then this, and again it should end at the middle of the next bit here. Clear? Then 0 is what? High to low. And so high to low. Again is what? 0. 0 is what? Sorry, again is what? 1. So low to high. So low to high. 0 is high to low. Now this one. High to low. Now see here. Now again my next bit is what? 0, which is same as the earlier bit. If this is the case, then instead of completing the signal in the middle, complete the signal at the start of the next bit interval. Means what? I have to complete this signal of 0 at this point only, because these are the two same bits. Okay, and again I have to draw the next one. So 0 is again high to low. So high to low. Again next bit is 1, so I have to go to the middle. See, next is what? 1. 1 should be low to high. So low to high. But again it is 1. So instead of going ahead to this line, what I have to do, I have to complete my this signal to this interval only, and again came back. Okay. Again 1. So again low, come to the middle and high. Again 1 is there, so complete the signal at the start of the next bit. Then again come back. Again 1 is low to high. Again 0 is there, so again middle of the interval. Then oh sorry, next bit is again, yeah, right, correct. So again come back. Then this one. Okay, again same bit is there, so finish it over here again. Then 0 is again high to low. 1 is there, so this one, and again go back low to high. Clear? समजतंय? It is quite difficult. थोडंसं difficult आहे. फक्त काय लक्षात ठेवा? 1 means low to high, 0 means high to low. Every transition should be at the middle of the bit interval. But if the two bits are same, then it should end at the start of the second bit. 0 and 0 are present. That's why I have completed this signal to the start of the bit interval. 1 and 1 is there. So I have completed this signal to this one. Again to this point. Again to this point. That is the only difference. If two bits are same, then only we have to think what to do. Otherwise, remaining things are same. Okay, let's solve one more example. Now, see it carefully. Mm, I mostly it is at the positive side only, because in most of the examples this zeroth line is not considered. We have to just draw this signal, but for the time being, means for to get understand, I have considered this zeroth line. So as it is 0, 0 means what? High to low. Okay, so I'll start this high to low. 1 is there, 1 means low to high. So from this low to high. Again 0 is there, so 0 means high to low. But here again the same bit is there. Okay. So what I have to do here, because zeroth is again what, why this we have to do. See, for 0 is there, it is high to low, and 1 is what, low to high. Okay. Now see here, हे का करावं लागते आपल्याला, इथंच का संपवावं लागते. See, when I came to this point, ठीक है, again what, 0 is there, the next bit is same as the previous one, and my 0 represents high to low, means what, I have to come over here, and in between I can't break the signal. ठीक आहे. जर मी सपोज याला इथं मिडल पर्यंत आणला, तर काय होईल, याचा जो 0 आहे तो याच्या 1 मध्ये जाईल. सो दॅट आय डोंट वॉन्ट. what I have to represent, I have to represent this 0 as the high to low, and to make this 0 as high to low, I have to complete this signal over here without breaking. I have to continue, and then I have to represent this 0 as high to low. That's why we are doing this. Okay. So this will be high to low signal. Okay, again 1, it is different, so low to high. Again 0, it is again different, so high to low. Again 1, low to high. Again 0 is there, so high to low, but again the same bit, so I have to complete it here only, and again go back, and for this it should be like this. समझलो? Any doubt? Yes or no? आधीचे सोपे होते. हा,
Yes, ma'am.
आवाज खूप खाली गेला सगळ्यांचा. येस येस. हा,
मॅम रिपीट करायचं.
रिपीट करू.
हा.
ओके, आय रिपीट वन्स अगेन.
Yes, ma'am. Repeat करा.
ओके ओके, करते करते रिपीट. लेट्स सी नेक्स्ट एक्झाम्पल. हा, ऍक्च्युली हे तुम्ही करायला ठेवते मी, हे परत एकदा एक्झाम्पल आपण टॉक करू. लेट इट बी. नेक्स्ट एक्झाम्पल विल सी. Okay, so remember Manchester encoding, व biphase Manchester आणि D-Manchester. These are the two types where we have to consider the signal at the middle of the bit interval. Middle means what? याच्या मध्ये ट्रान्झिशन लक्षात घ्यायचंय. मी सांगते की प्लीज मम्मा 2 मिनिटं दे. Okay, so sorry for the disturbance. Let's see the example again. So Manchester and de-Manchester encoding. So याच्यामध्ये काय होतं? Am I audible ना?
Yes,
Yes,
ma'am.
ma'am.
Okay, okay.
Yes,
So,
ma'am.
okay, so Manchester and de-Manchester. So your signal should represent at the middle of the line. असं सिग्नल दिसणार आहे आपला. Now, in case of the Manchester, one should be low to high and zero should be exactly reverse as a high to low, right? Then next, let's see how it is drawn. So it is easy to remember, but only what we have to do, if same bits are there, 0 to 0 or 1 and 1, if same bits are there, what we have to do, we have to end the signal at the start of this next bit. Means instead of going to the middle, I have to end the start at the start only. Similarly for every bit. Okay, let's see how to draw. 0, then positive, then negative. Now 1. So 1 represents low to high. So my signal will start as this low, middle ला येईल आणि middle मधून पुन्हा high ला जाईल. Up to this 0th middle. ठीक है. Then next bit is what? This is 0. 0 represents high to low. So it will be high to low to the up to middle of the next one. Again 1 means what? Low to high. So go up low to high. 0 represents high to low. So again high to low. I came over here, but now for this next bit is what? It is again 0. Okay, now what I have to do here is, as these two bits are same, first 0 and next 0, again these two are same. Now what I have to do, माझा हा सिग्नल मिडल मध्ये न्यायच्या ऐवजी
Hello, ma'am. Your voice is not clear.
Ma'am, your voice is breaking.
हाँ आवाज ब्रेक होता है मैम.
हाँ.
Okay, actually let them wait for a minute. Okay, now is it clear?
Yes, ma'am.
Yes ma'am. Yes ma'am.
Okay, so हे दोघ जण काय सेम आहेत, मग ह्याच्या मिडलला जायच्या ऐवजी मी काय करणार आहे, तर हा सिग्नल इथंच ब्रेक करणार. दॅट इज द ओनली डिफरंट थिंग. ठीक आहे, सो आय हॅव टू ब्रेक झाल्यानंतर नेक्स्ट बिट अगेन 0. सो हाय टू लो, अगेन high to low, means again I have to go to the high and again I have to make it as a low. अगेन इथे 0 असल्यामुळे पुन्हा मला काय करायचंय, सेम बीट आहे. दिस टू आर सेम. हे दोघ जण पुन्हा काय आहेत, सेम आहे. म्हणून पुन्हा मला काय करावं लागतंय, हा सिग्नल इथेच ब्रेक करायचा अँड अगेन आय हॅव टू गो टू द हाय अँड मेक इट एज अ लो. ठीक है. Now next bit is 1. So they are not safe. So I can move forward to the middle. Again, these two are same. ठीक है. So what to do now? 1 represents low to high. So go low to high. But as it is 1, which is same as this one. So instead of going in the middle, what I will do, I will end this signal over here only. Again, I'll come back and again I will make it as a low, one as a low to high. Hmm? And 0, it is again different. So I should go for this and I will make it as a high to low. Simple. So this will be the signal representation. समजलं? थोडं समजलं का? एक 30% समजलं
Yes.
असेल तरी इट इज ओके. एक्झाम्पल सॉल्व करताना एकदम क्लिअर होऊन जातं. थोडस समजलंय बिट्स कसे इंटरवल्स मध्ये जातात.
Yes, ma'am.
आता ओके, आता एक एक्झाम्पल देते, ते सॉल्व करा. शांत डोक्याने सॉल्व करा हे एक्झाम्पल सेम. काय करायचं आहे आणि नंतर मग मी काढते, त्याच्यातून चेक करू आपण. ठीक आहे. सो आय राईट हिअर what the 0 is representing. 0 is high to low and 1 is low to high. Now start. ड्रॉ करायला स्टार्ट करा. बघूयात येते का. चेक इट बाय युअर ओन. डन.
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, I'll draw. Let's check. Maybe it may be possible that my signal will be wrong. Please let me know. So I'll start. So first bit is 0. So it is high to low. So high to low. But again it is 0. So I have to complete it. Again I have to go up. Then high to low. Next is 1. So I can continue. Then 1 is low to high, but again 1, so I have to complete it over here only. I can come back again low to high. Then 0, it is different, so high to low. 1 is there, so it is different. Again 1 is means 1 is low to high, low to high. 0 is there, so high to low. 1 is there, means low to high, but again same bit is there, so I have to complete here. Again come back, then low to high. Again 1 is there, so again come back and make it as a low to high. Correct? Is it correct?
Yes, ma'am.
वेगळं
Yes,
काय
ma'am.
आलेलं?
Yes,
सगळ्यांचं
ma'am.
Yes,
आले
ma'am.
बरोबर?
Oh, yes, ma'am.
ओके ओके, गुड वन. सो अजून एक एक्झाम्पल, हे सेम एक्झाम्पल सॉल्व करा, व्हॉट एव्हर वी हॅव सॉल्व, सो दॅट यू विल गेट कॉन्फिडंट दॅट यस वी आर करेक्ट. सेम एक्झाम्पल ड्रॉ करा अँड चेक इट whether your signals are getting correct or not. Ether, are you getting the signal correct way? Yes. Are you getting the signal?
Yes, ma'am.
Okay. So,
Yes, ma'am.
okay. Everybody has understood now Manchester and D Manchester. Sorry, Manchester encoding.
I hope everyone has understood and got the signal correctly. Now let's see the next one.
Based encoding. Okay. The next type is what? Differential Manchester. Hmm. So again, it is same that in the differential or D Manchester, again we have to uh, draw the signal in the middle of the bit interval only. So in this type of the encoding, there always occurs a transition in the middle of the bit interval, same as a Manchester encoding. Now, what this zero represents? Zero means no inversion. Okay, means what? Whenever zero occurs, go back to other side and again come back to the main side. Now, what is this zero? Whenever zero occurs, go back to other side. Other side means if I'm at positive side, go back to the negative side. If I'm negative side, go back to the positive side. And again came back to the main side. Remember, जर पॉझिटिव्हला असेल तर मला काय करायचंय निगेटिव्ह साईडला जाऊन पुन्हा पॉझिटिव्ह साईडला यायचं फॉर झिरो and 1 is what? It is inversion and transition always start from a positive side. These are the rules. Okay, now see carefully how this will happen. So what we have to do here is what? 0. It is what it represents? No inversion or positive, negative and again positive. Okay. So positive, in short I'll write negative and again original position, that is positive, and one means inversion. Inversion means जर पॉझिटिव्ह असेल तर त्याच्या इन्व्हर्ट करायचा. ठीक आहे. and always starts from positive. वन आणि झिरो काही असेल तर काय करणार आपण पॉझिटिव्ह पासून स्टार्ट करणार. Okay, let's start. Now it is also in the middle of the bit interval. So first bit is what? 0. So I'll start from the this one negative, sorry, positive side. So from this it will get started. Now what the 0 represent? Whatever 0 occurs, go back to other side and again come back to the same side, in middle. Now I have started over here. This, what is this? It is my positive, this is my negative. So what the 0 signal should represent? It should, or it has started from positive, it should go to the negative and again it should come to the positive side, that is 1. Right? Let's start. Let's see what is the meaning of this one. So it is started, it goes to the other side and again it came to the original side. This one. No zero la high to low, 1 low to high, nothing. What is meaning of 0 is what? जिथून तुमचा स्टार्ट झालेला आहे 0 त्याच्या अपोजिट साईडला जायचं आणि पुन्हा ओरिजिनल साईडला आणून त्याला कंप्लीट करायचं. So this is the signal for the 0 to 1. Okay. Now one is what? Inversion. Now inversion means what? Go to the opposite side. So it will go to the middle and again it will be the this one negative side line. Again what is this? 0. Again 0 ला काय होणार आहे माझं? Again it will go up, then middle, again it will come back to the original position. Again 0 is there, same process. 0 up, so again came back to the original position. Now 1 is there. 1 means what? Invert करायचं. So continue and do the inversion. ठीक है? Again 1 is there. So I have to invert means reverse. We have to do. It will come over here. Now again 0. 0 means, so I'll start from negative side. So it will go to the positive, then again it will come back to the negative side. Again 0. So I have started from negative. So again it will go up to the positive. Then again it will come back to the negative. Again 0. Again it will go to the positive. Then come back to the negative side. 1 is there. Invert means we have to draw the signal and make like this. Again 1. So invert it. So my signal will look like this. Clear?
Yes, ma'am.
समजलं सगळ्यांना? Yes or no? I hope थोडंसं अवघड गेलेलं आहे. Okay, one more example I'll show you. So this example we will take and we'll stop. In next lecture again I'll revise the differential Manchester. Don't worry. So 0 is there, positive is there and negative is there. So what 0 represent? Original position, opposite position and again original position. And 1 represent inversion. इन्व्हर्जनचं मिनिंग काय असणार आहे? जर मी पॉझिटिव्हला असेल तर निगेटिव्हला सिग्नल ड्रॉ करायचा, निगेटिव्ह साईडला असेल तर पॉझिटिव्हला सिग्नल ड्रॉ करायचा. अँड ऑलवेज स्टार्ट फ्रॉम अ पॉझिटिव्ह फॉर 1 or 0. Okay, let's see. So 0 is there. 0 means what? Starts from positive or negative, again go back to opposite and come back to the original. But first bit, for first bit we are always starting from positive. So let's start. So 0. So I'll start from positive, then again it should or it is at negative side and again it should go to the its original position. Again 0 is there. So again from positive it will go to the negative and again it will come back to the positive side. Okay, then 1 is inversion means what? This will go to the opposite side. Again 1 is there, so continue and make it as the opposite. Okay, then again 0, so positive, it is at positive, then it will come to the negative, again it will go to the positive. Again 1 is there, so make it invert. Again 0, then negative to positive to again negative. Again 1 is there, so this one. Again 1 is there, so this one. Again 1, so invert like this. 0 positive to negative, again positive. Again 0 is there, so positive to negative, again to the positive and 1 is invert. Clear? Maybe at initial stage everything will look same. You will think that what we have changed, nothing. असं वाटतं पहिल्यांदा. But whenever we will solve the example and we will look after the rules and according to rules, if you have solved the example, then definitely you will understood the difference between every type. प्रत्येक टाइप मध्ये डिफरन्स आहे एन्कोडिंगच्या. आता इनिशियली आपल्याला वाटतं की काय सेमच आहे, पॉझिटिव्ह निगेटिव्ह नो, इट इज टोटली डिफरंट. ठीक आहे. फॉर एव्हरी एन्कोडिंग टेक्निक द रूल इज डिफरंट, द रिप्रेझेंटेशन ऑफ 1 and 0 is different. Whether it should come to the zero or not, how it should travel, whether it should be at the start of the line or middle of the line, that we have to keep in our mind, and it will get changed. Okay, so today we'll stop here. In next lecture I'll give you two example, solve it, try these two example today. Again for the next lecture we will see this type. Okay, so just take this example for your practice. 10.
Ma'am,
Yes.
ma'am, is there any session for us
Actually I don't
today?
got any message. I don't got any message. If there is a session, it will start at regular time only in 11:15 only. Maybe session or your regular lecture. It can be anything.
Okay.
So take this example: 10100111101. Okay, and this. Okay, solve this example only. Try for it. Okay. So whatever we have seen today, I hope these techniques are getting clear. I'll share you the PPT today. So from that you will understood. Try to solve all these example, and you will understood the difference also. Okay. So we will stop here.